All right, so I picked this Homelite LRE4400 generator up for free back last fall, along with that toolbox and some other stuff. And I've just now got around to uncovering it. I'm going to start working on it. I'd like to try to get this thing running so I can have it around, and it'd probably come in handy. It's been mounted to some kind of homemade dolly system here, which is all right, other than it's pretty big and cumbersome. And I think I may end up taking it off actually and just keeping it in the cage that it originally came with. Maybe put some casters on it, some small ones to wheel it around, make it a little more compact. It's got this rod mounted for some reason. I'm not sure if they were hanging lights or something off that or what, but it's dirty. It's been setting around for a while. I don't know anything about it. I don't know if it's seized up, if it runs, if anything works, but I'm going to tear into it and find out. Do what it takes to get it running again. Looks like there's maybe some custom welding on this exhaust here too. Homelite 4400 watts, 8 horsepower. Long life cast iron sleeve. We'll see. Electric start. Electric start's pretty nice. It doesn't even have the pull rope in it. I don't know if it had a backup at one time, but like I say, I'm going to disassemble this whole thing, fix it up, change the oil, do whatever it takes to get it running and bring it back to life. So we'll see what happens. Just out of curiosity, I wanted to see if there's any charge on this battery at all. I highly doubt there is. Well, it's not real corroded. Yeah, it's 2.8 volts, so it's probably sulfated. Yeah, there's obviously been some custom wiring done to this. Yeah, I'm not really sure what's going on there, but that power wire is seriously corroded, so I have to get that fixed. Yeah, for some reason it looks like they were using some AC wiring that they spliced in here. I guess maybe that's all they had on hand when they were doing this, but awfully stiff. All right, this main power wire that comes off the positive terminal on the battery, it comes around to the other side, ties into the starter switch here, and then of course it completes the circuit and feeds back over to the starter solenoid. I want to test this just to see if the starter switch is actually good, so I'm just going to do a continuity test. All right, looks like the starter switch is good. I'm going to start cutting the cage that the generator's mounted to off this homemade dolly that it's been welded onto. It's going to be a lot easier to mess with if I can get it up on the bench, and I don't think I'm going to use this dolly anyway, so I'm going to start cutting on it. All right, I've got it freed up now. I want to get it up on the workbench Like start doing some more disassembly. Plug's got a lot of carbon on it, but looks like it's okay shape. There's something going on here on top of the motor. It almost looks like brazing. I'm not really sure why exactly this cover here would be brazed, but we'll have to dig into it and see what's going on there. All right, so now that I got this thing up on the bench and I can take a little closer look at it, I realized that I was mistaken earlier calling this a starter solenoid. There's no solenoid involved in this starter. It's just an inertia driven, probably Bendix style. I'm going to take this side plate off here and confirm that. But this main power wire that comes from the starter switch goes directly to the armature, and there's no solenoid involved. This I thought actually went to the starter somewhere, but the wire's pinched back here, and I'm gonna have to take a few things apart to see what it actually goes to and figure out why it was spliced on to the power wire. So we'll get started and see what we can find out. So we can see the starter pinion here. It actually feels like it's a plastic gear. There's somewhere on the leading edge of the tooth, but yeah, it appears that it's the inertia style. I think you call this a Bendix, and this starter motor here is a permanent magnet DC. You can feel the cogging as you rotate the shaft here. It actually, this starter pinion setup feels kind of chintzy, but I guess it works. We'll find out. We get her cleaned up and hook a fresh battery up to it. All right, so I took the starter off here so I could see what was going on with this wire. It's been spliced together, and it was going to the positive terminal on the battery. And looks like it goes to the alternator, so that's reasonable enough. And it also looks like the motor's turning over. All right, since I've got this starter off, I'm just going to go ahead and hook it up to a battery I had laying here with jumper cables directly, just to make sure that it still spins over. All right, I've got the starter down here on the ground. I just hit it with the wire wheel a little bit, and it does actually work. So you can see the Bendix setup here. When you have forward inertia, it slides the starter pinion in, and then when the inertia changes, you can see that it drops back out of engagement. Air filter doesn't look bad at all. Well, this fuel hose is nasty. I'm going to be replacing that for sure. Be interested to see what that fuel filter looks like, but there's definitely some stuff in there. The tank is empty though. There's some residue in the bottom. Dirt mostly it looks like, or maybe a little bit of rust. So I can get that knocked out, and luckily it's plastic, so the tank itself's not actually rusting. So I can just flush it out and clean it up and put it back into service. Yeah, it's got two 120 volt plug-ins and then one 240. It's probably a 20. Yeah, it says here it's a 20 amp. Definitely something shaking around in this fuel filter, so that's going to be replaced. So I think I've figured out what this light's all about here on the front. I'm pretty sure it's a warning indicator light. I noticed that on the above the faceplate here, it says that this has a low oil shutoff protection. Well, that's about the only thing it could be, and this would be your warning indicator. And I noticed that this wire is actually cut here and just taped on. And I'm pretty sure what it does is it goes to this. It looked to me, I was looking at it earlier, and it looks like this is for an electrical connection here. And most likely this is the oil pressure switch. So if the oil pressure gets below the calibrated threshold, then the switch would close, it'd complete the circuit, the light would turn on, and then the wiring goes over here. I'll have to dig into that a little closer and see what exactly is going on, but it kills power and shuts the motor off to keep it from burning up, which is a decent feature, especially for something that's going to set running unattended for long periods of time potentially. Well, I'm gonna probably reuse this exhaust, but I'm gonna clean it all up. I I got the old welds ground down on this rigged up exhaust here. I fixed those up. So I don't know if it was leaking before, but there was a lot of porosity in those welds, so I've got that cleaned up now. And I've been putting some rust converter on here just to try to help keep it from rusting apart on me. Well, you can see on this low oil switch here, when the oil level's up, of course this back float rises, disconnects, there's no completion of the circuit. When oil gets below the threshold, it drops down, it makes contact in here, and you have the connection here that allows current to pass through the shut-off circuit. And I think I'm going to try to just clean it up and see if I can get it to work again. Well, the bulb that was on here is burnt out. Just to demonstrate that the low oil switch actually works now, I'll use this half amp test light that I have just to show that it does indeed provide a path to ground. Well, it looks like this was brazed due to some cracks that had formed in the top of this case. And for whatever, I'm not entirely sure what all is connected here with the on and off switch, but that's gone now, so I'm just going to have to work around that. But anyway, I ground this down a little smoother. I'll probably just put a little paint over it and use it as is. I decided to do a little research on the oil shut-off and the ignition on this unit, since there were some pieces missing, especially with the kill switch, and the low oil shutoff was unhooked. So what I was able to determine is that my ignition is the Briggs & Stratton magnetron style, which is newer than the old points and condenser. This is actually a solid state device. It's got a Darlington pair of transistors in it that actually does the switching, along with a a trigger coil. And I decided to kind of draw up a schematic here of the circuits from what I could find on the internet. If we look at the circuit for the wiring here, what we have is the ignition coil and then two pathways from there that you can actually kill power to. If you turn the kill switch to the off position, it actually provides a second path to ground across the primary winding on the ignition coil. And the other path is through the low oil switch. So if the oil's low, the switch closes, you get a second path to ground through the primary winding. That means when the magnet on the flywheel rotates by, it doesn't build up the inductance like it normally would, and instead it flashes the warning indicator lamp. So if you're turning it over and you're trying to start it and the indicator lamp's flashing, obviously letting you know that you're not getting any spark. And we can see here this is representative of the solid state switching device inside the magnetron. We've got the primary coil, laminated iron core, and then we've got the secondary winding over to the spark plug and return path through ground. So what I could find, I don't know if this is simplified or if this is actually the schematic for the magnetron, but we actually have three coils. We have the trigger winding, which gets a small voltage, only about a volt, and allows current to flow into the base of this transistor, which passes more current to the base of the next transistor, your Darlington pair here. Then of course that allows full current to flow through the primary winding, and then as the magnet continues to rotate by and changes, then that shuts off current flow from the transistor, collapse that magnetic field. You get super high voltage, 20,000 volts, 40,000 volts potentially build up in the secondary winding, enough to jump that air gap of the spark plug and get your spark. So anyway, I thought that was kind of interesting, and since I was going to have to fix the wiring, I figured I better understand a little bit more about it. All right, I've got the starter hooked back up. It's turning over pretty slow. I'm doing voltage drop test across the different battery cables. Let's see. And I have about over 1 volt drop on the negative lead, so I may have to look into that and see where the lead's awfully small. That could be the problem. I'm going to try it on the power wire next. All right, there's pretty much no voltage drop across the main power leads. All right, so I ended up just doing a delete on this wire here. It was on one of these motor mounts, and I'm almost sure it wasn't the factory after I got to looking at it for a while. It's too small of a gauge. There was also this wire that was hooked from the bottom of the generator and went to the frame back here. I got to looking at it, and it's 4-gauge battery wire, so I'm almost sure that this would have went to the negative terminal. And I've got the power wire here. I got to figure out what kind of battery I'm going to have, and I'll figure out which kind of terminal to put on it. And then I made sure that both of the jumpers in between the motor mount bushings were good now. I have good connection between those. So I did a test earlier with this wire, and there was too much voltage drop across it. I thought about going with it, but the motor was turning over kind of slow, so I decided to swap that out now with this and shouldn't have any more problems. So here's all the wiring delete that I did. Most of this stuff I don't think was factory anyway, other than the light switch here that was burnt out. So I've got rid of all that now. Got alternator wire extended. It seems like it's awfully small gauge for alternator, but figure that out when we get it running. But I think I've got all the wiring cleaned up now in good enough shape, and I can get started on getting the carb cleaned up and put it back together. So I just ran this carb through the new ultrasonic cleaner that I got for about 20 minutes with some Simple Green, and it took the vast majority of the grease and the buildup off of it. There was a lot of powder and sediment in the bowl here, and it cleaned all that right out. The jets seemed to be cleaned out. I ran a small wire through them as best I could tell. I didn't want to disassemble it too much further than this. I did take a couple of the jets out, and I think it done a really good job. So I'm going to start reassembly. Hopefully this is cleaned out enough now where it's going to run, and if not, I'll take it back apart and do a little more cleaning. Since the kill switch was broken on this also, I bought a replacement. It's not a direct replacement, just a single pole, single throw switch here that I'm going to wire up on the front cover to be able to kill the engine. And then also the fuel tank bushing on the bottom of the fuel tank where the fuel shutoff valve goes was leaking pretty bad, so I got a new one of those. So I'm going to clean up the shutoff valve here. It's a little rusty, and I'm going to replace that bushing, and this thing should fire up and run. Here's what I've got going on with the kill switch. I've got this replacement now where the old switch was, and I'm just grounding it out here where the front cover attaches to this mounting point coming off the motor here. So it'll be grounded out and should work just fine. All right, so I think I've got everything working on the engine side of things. Turns out this alternator wire is supposed to go to the negative terminal of the battery. For whatever reason, the voltage was opposite polarity coming off it. And I got everything put back together. I got my on and off switch wired in here. I had to do a little work on the starter switch. It wasn't working properly. And I also had to change out the fuel line and the fuel filter. Of course, the fuel filter was nasty, and this one fuel line was leaking along with that tank bushing. I changed the motor oil in it, done a little work on the governor here, and she should fire right up. So outside of needing to make a few adjustments on the carburetor, it's pretty close, but I think it needs fine-tuned a little bit. I tried plugging in here and also ran the multimeter in these outlets, and I'm not getting any power coming from the generator portion. So I think this would constitute enough for a single video, getting the motor and everything running. And I think I'll make a part 2 of me tearing down the generator portion, trying to diagnose it and seeing if I can get it to actually produce power. So stay tuned for part 2, and thanks for watching. Before I sign off, I thought it'd be funny to show what my garage looks like now. I almost never have stuff this strung apart. I mean, I've had to fix pretty much everything on this generator. It's pretty well a piece of junk, but it's kind of fun to see what you can do to fix things up. But I mean, I have the entire garage torn apart. I've got every drawer and toolbox open, stuff laying all over the place, bolts out, all my electrical diagnostic equipment, just a real mess. Anyway, thanks for watching.